Hello everyone, welcome back to Absolute Value. The IB math test is coming up, so I just wanted to do some problems here to get you all ready for that exam. So a few problems I'm going to do today are some of the Section A problems on the AA IB math exam. And these problems are both on the higher level version and on the standard level. So let's get started here with our first problem. Number one, we have let A and B be events such that probability of A is 0.5, probability of B is 0.4, and the probability of A union B is 0.6. Find probability of A given B. So there are a few things that we know. We know the formula for this, and I'm just going to write that down right away. Probability of A given B is the probability of A and B over the probability of B. We have this. We don't have this, but we know another formula that can help us find that. So when we're finding the probability of A union B, we can remember the formula for this by thinking about the picture of a Venn diagram. If we want A or B, that's this whole thing. So if we take everything that's in circle A and everything that's in circle B, we would be duplicating this part, so we have to subtract the intersection. And then that would give us the full union. In a formula, we would have that be. This is what we now need for this first problem. We have this, we have this, we have this. We can just plug everything in and find our answers. So P of A union B. Now we can solve for this. And if we want to get 0.6 and we have 0.9 minus a number to get 0.6, we know that this right here must be 0.3. Now that we have our A intersect B, we can go back to this formula and we can substitute everything in we have, which is 0.3 and the bottom is 0.4, and this is going to give us 0.75 or 3/4. All right, so there's our final answer. This question is worth 5 points, so make sure you get each of those points. You get 1 point for writing this formula, 1 point for writing this formula, 1 point for substituting in to the formula, 1 point for getting the intersection, and then 1 point for getting the final answer. So that's where your 5 points would come from for this one. So make sure you don't skip any steps, like starting out with the original equation. IB is very particular about including that. All right, so that's number one. Let's go on to number two. Number 2A is we are going to show that 2n minus 1 quantity squared plus 2n plus 1 quantity squared is equal to 8n squared plus 2. I'm just going to start on the left side here, and I want to just multiply out these terms. I'm going to keep the right side the same and do all my work on solving on the left side until we get the left side equal to the right side. We would get that when we expand it out. And now if we just distribute here, we should get, if we combine like terms, we have 2 of these n squareds. So 4n squared plus 4n squared, 8n squared. We have a negative 4n plus a 4n. Those things cancel each other out. And then we have plus 1 and plus 1, which is plus 2, which does equal our right side of 8n squared plus 2. So there's part A. Part B, we want to prove that the sum of the squares of any 2 consecutive odd integers is even. Now, nicely enough, they gave us 2 consecutive odd integers right here and squared them and found the sum of them. So for part B, here's where we might want to do some explaining in words. So 2n minus 1 and 2n plus 1 are consecutive odd integers for n being in the integers. We know that. And the sum of their squares equals 8n squared plus 2, which we just showed in the previous one. And now to show that it's even, all we have to say is that this is a multiple of 2. So since we can factor out a 2, since this can be factored like this with a 2 factored out, that means 8n squared plus 2 is divisible by 2. and even. And therefore, the sum of the squares of two consecutive odd integers is even. So this question is worth 3 points for part B, and here's where you'd get them. Right here, and right here. So there's 3 points there. Make sure you get all of those points for that question. For part A, we would just get a point here for simplifying and a point for getting it to be the same answer. All right, so here is your final answer for number 2. Let's try another one. Here's number 3. They give us the derivative of f is 8x over square root of 2x squared plus 1. And that this point f of 0 is at 5. And now our goal is to find f of x. So since we're starting with f prime of x and we need f of x, we know that we are going to integrate. So let's integrate 8x over square root. So in order to take this antiderivative, we need to do some u substitution. I'm going to write over here on the right what our u and du are going to be. So our u is going to be this bottom part in the square root, the 2x squared plus 1. And then we need our du of that. So that's the derivative of this part, which is 4x dx. So let's solve this just for dx so we can substitute in for dx here. This is going to be 1 over 4x du equal to dx. And then let's substitute things back in terms of u. We're going to leave the 8x the same for now, over square root of u. Dx is this, 1 over 4x du. Now we have some things we can cancel out. So x on the bottom and x on the top, and we can simplify the 8 and the 4, that's a 2. So to just simplify this, it's the antiderivative of 2 over square root of u du. So this is kind of like a power rule, where the power of u in this case is going to be negative 1/2 because it's on the bottom there. I'm going to just write it out. This is how I like to do it. Like this, so we can see it's a power rule. And then we can take the antiderivative. So now we add 1 to the exponent, so it'll make it a positive 1/2, and then divide by 1/2. So 2u to the 1/2 divided by 1/2 plus c, which this is the same as 4u to the 1/2 plus c, or rather 4 square root of u plus c. Now we need to plug our u back in. So this is going to be 4 square root of 2x squared plus 1 plus c. Do not forget the c, the constant of integration. But at this point, we can plug in this point that they gave us. We can plug in 0 for x, 5 for f of x, and see what we get for c. So 0 plus 1, that's 1, square root of 1 is 1. So this is just 5 equals 4 plus c. So that means c is 1. So now the last thing we do is make sure we plug it back in here, and we'll get... So there's our f of x. And just to walk through really quick where you would get your points here to make sure you are getting your full 5 points. From the beginning, right once you turn it into an antiderivative, this gives you your first point. Once you put it into u substitution, this gives you your next point. Once you find this antiderivative, this gives you your next point. Successfully plugging things in here gives you your next point, and then your final answer gives you that last point. Okay, let's do one more problem here from the section A. This one gives us functions f and g defined such that f of x is x plus 3 over 4 and g of x is 8x plus 5. We are going to show that g of f of x equals 2x plus 11. So when it comes to these compositions, we always want to start with the function that is closest to the input, which in this case is x. So first we're just going to take f of x and we're going to do g of f of x. This is another way to write this. So first we're just going to start by plugging in. So first we're going to start by putting our f of x right in here. So this is going to be g of x plus 3 over 4. Now this f of x function is the input for g. So we go to our g equation and we say, okay, now we have 8 times x, which this is now our x, plus 5. And then we can just simplify this a bit. And if we distribute that 2, we will get 2x plus 6 plus 5. Combine like terms, we get 2x plus 11. Part B says that given that g of f inverse of A is 4, find the value of A. So the inverse is basically saying, well, if we put the output into the inverse, we'll get the input. So all this is saying is that the input is 4, what's the output of this function we just came up with, which is g of f of x. So all we have to do here is do g of f of 4, and we know g of f is this function right here, so just plug in 4 for x. And so we know that is equal to A. So then in terms of our points, we'll get this first part is worth 2 points, so we get 1 point here and 1 point here. The second part is worth 3 points, and we'll get 1 point here, 1 point here, and 1 point here. So those were a few problems from a past IB Math AA exam, and I'm going to make a few more IB videos to review before the exam, so make sure you subscribe to see that content. As always, leave comments if you have questions that you want me to do in particular. Thank you for watching, and have a great day. Happy studying!